This will be a 1 or 2 part video where I construct this kit. This is what it should look like when it's done. This is what it looks like now. It's a typical Chinese kit. It purports to be a 20 amp, 200 volt, 1969 power supply and speaker protection device suitable for the 1969 amplifier. Okay, 1969 refers to the amplifier developed by a man by the name of John LINSELY-Hood in 1969. The amplifier draws typically less than 1.5 amps, and this unit is supposed to supply 2 of them, so perhaps 3 amps. The 20 amp refers actually to the size of the full wave rectifier. There's no way this board, these connectors, would handle 20 amps. The seller provided a board layout. This board calls out a full wave rectifier that's rated 16 amps, and it calls out 10,000 microfarad electrolytic capacitors. The board delivered with what's called a 20 amp power supply calls out a 20 amp full wave rectifier, and then the board specifies a pair of 22,000 microfarad capacitors. So I think that this refers to perhaps revision 1, a 16 amp circuit, which means lower rated rectifier and lower rated filter capacitors. It's maybe a little thing, but these 4 mounting holes are completely isolated from anything. There is, however, a mounting hole here, which puts it right here, that is connected to the negative side of the power supply or the ground. And the board that came is called a Rev 2 board. When I get a Chinese kit like this, I try, don't do it all the time, I try to develop a schematic, a board layout, and some notes that apply to the design. For this one, I also put together a bill of material. It's not really a complicated board. The kit did not include the filter capacitors. That is, these 2. The power supply is just a simple brute force device using full wave rectifiers, which necessitates a center tap transformer. Looking at the design overall, I would say it was intended to use 24 volts. And I talk about this in my transformer notes. In any event, it's just a simple 2-diode full wave rectifier, 2 big electrolytics, 1 small, very small capacitor, and output connections, minus and plus, for 2 amplifiers. So there's nothing at all special about that. The speaker protection circuit turns out, I believe, to be just a time delay on startup. That is, time delay on connection of the speakers to the amplifier. What they've done is tapped 1/2 of the transformer. That is, they've tapped this connection and this connection. So they made a 24 volt AC input power supply, filter capacitor. I have no idea what this resistor does. A relay coil, a Darlington connection that would power the coil if the Darlington was in conduction. It looks like conduction is delayed by the limiting of the current through this resistor. A small amount of current flows here, a charge builds up here across C5. At some point this begins to conduct enough to pull up the relay. There is a surge protection diode connected across the relay, as well as an indicator LED. So power on, we power this up immediately, we power this immediately, and after some time delay we energize the relay. The output from one of the amplifiers, or both of the amplifiers if it's stereo, will be applied here through a 10 ohm resistor to ground. So the load on this amplifier, or this one, is 10 ohms until the relay pulls up and these contacts change state. This opens, this closes. The amplifier is connected to the speaker. And the same thing on the other channel. So all that this does is power the amplifier immediately, or very quickly, and transfer the speakers to the amplifier after a time delay. I hope. The whole thing looks pretty simple. Everything is through hole, no surface mount. I'm going to start with the smallest, that is the devices that protrude the least above the board. So that would be small devices that lay flat. The four lowest, closest to the board components are these three resistors in this diode. Now, the resistors are not polarized. They can be installed either way. They do have color codes on them that start here and read in a certain direction. I always like to read from left to right, the same as I read a printed document. So this is a 68K, so the first line, first color band indicates a 6. 300K indicates a 3. So I'm reading this direction. The diode, however, is polarized. See, the diode marking here is a black mark at one end. And here's the diode. It has a marked silver band at one end. So this diode goes this way, not this way. I tend to bend components by eye. You can get something like this where the component is bent to a specific lead dimension. Another one looks like this, where you would lay the component down in the appropriate space hole. And then bend the leads. Problem comes in what's the appropriate space hole. most of the time pressing it down allows it to be the right lead length. With through-hole components, I like to use these blocks with spacers on the bottom so that the leads can stick through and not rest on the board. Then just turn it over and solder it. That works all right until the components grow above these blocks. Then when you turn it over, you end up resting on your components. These are available from a place called QRP-Me. I'm not affiliated with them in any way. Probably next will be these 10 ohm resistors that are bigger. Okay, the size of the resistor indicates the wattage. These are probably 1 or 2 watt. Again, you see the holes are just about as long as the resistor. So fold the leads. And there we go. Unfold them real tight. I did the first one tightly, so I'm just going to sort of bend them down. See how that works? No problem at all. Now, do not install too many of the components before you begin soldering. I wouldn't solder every component, but very many components you get into a forest of wires, and things become a little difficult. I'm wearing glasses. I suggest you beware of flying leads. If not for your eyes, because these leads fly all over the shop and sometimes get lodged in places you don't want scraps of wire lodged. Alright, we have a little capacitor here. It's not polarized, but it does read. So I'll make it read left to right. There are 2 transistors. They're located here and here. They are identical. The leads as they are won't fit the holes, but they are in a straight line, so we just widen the leads out a little bit. Flat side indicated on the silk screen. The flat sides go this way. Just press them down until they look fairly close. Spread the leads out a little bit to keep them in place. And repeat. We have a four-legged, four-lead bridge rectifier. It's perfectly round. The data sheet, which is in the directory below, as well as the silk screening, indicates a flat side. Well, they forgot to flatten the side. The board indicates a 2W10, which is a 2 amp, 1000 volt device. The device provided is a 2W02, which is a 2 amp, 200 volt device. And you see there's a plus sign and then two wavy lines. This plus sign coincides with the lead. The two wavy lines coincide with two opposing leads. Silk screening indicates a plus sign. My drawing indicates a plus sign, two wavy leads, and a minus sign. If you get the lead adjacent to the plus sign, you'll notice it's longer. That's the positive lead. If you put the positive lead in the positive hole, everything else just fits. There we go. Now we slide it down, and we're done. Plus sign sort of up in the corner, that way. You can go ahead and push it down flush with the board. And then we'll go ahead and solder again.